Welcome to Deep Dive episode 2. This series is not just a paper discussion, we use this to discuss and comprehensively understand the whole syllabus through past papers. So, this is from question number 5 to question number 10. Let's start right away. So, the sixth question: heat is transmitted from the sun to the earth by what? What's between the sun and the earth apart from few planets and few debris in the space? We have the space. Space is empty. It's a vacuum. It's nothing. There's no medium or particles inside the space apart from those planets and debris. And we have three different types of energy transmission. Heat is an energy. So let's talk about the first one, conduction. Conduction is the transfer of heat or energy through direct contact between particles or substances. It occurs when hotter particles transfer energy to adjacent cooler particles. Then those cooler particles get heat up and they pass it to the next cooler particle. So it leads to a net flow of heat. This requires a medium or particles. Then we have convection. Convection, I think you might have heard this word convection because there's a convection setting in a lot of ovens. And if you know what an air fryer is, you know what an air fryer is. An air fryer uses convection, as in it uses hot streams of air to fry it. That's why it's called air fryer. Convection is the transfer of heat or energy through the movement of fluids. Fluids include liquids and gases. I need to remember that. So it aren't just liquids. Includes liquids and gases. And it involves the bulk movement of particles within the fluid due to the differences in temperature and density. Requires a medium. Have you ever seen a big fire, like a bonfire, and you can see like little particles of ash just going up from the bonfire, and it goes it comes back again after a little while. Or if you've seen hot air balloons, because of the hot stream of the air, the balloon goes up. When air heats up, or fluid, any type of fluid heats up, the kinetic energy in these air particles heightens, right? Temperature is measure of kinetic energy. So the faster these particles are, the more further apart they become, because the particles normally vibrate, and when it heats up, the vibration goes further than what is normally there. So in the same amount of volume, the amount of particles in it becomes less because it expands, right? So because of this density difference between cold air being dense and hot air being less dense, the hot air goes up, and this comes back round and round. If it's like a closed space, like our air fire, it becomes like that. So the next one is radiation. Radiation is a transfer of heat through electromagnetic waves such as infrared radiation, visible light, ultraviolet radiation, X-rays, gamma rays. They are all electromagnetic waves. Unlike conduction and convection, radiation does not require a medium. Radiation does not require medium, and it can occur through a vacuum. So we get the answer here, because space is a vacuum. Radiation does not require medium, so the answer is radiation. Next, we go to the next question. As was extracted by a student from an environmental pyramid, the ecosystem has one producer, 8 primary consumers, and 23 secondary consumers. The student has extracted this information from what type of pyramids? We have 3 types of pyramids: number pyramids, biomass pyramid, and energy pyramid. A number pyramid is the number of individual organisms at each trophic level. Trophic levels means like one tier of the pyramid within an ecosystem. It shows the relative abundance. I mean, abundance means the amount of something of organisms in different trophic levels. This is basically number based, right? Then we have biomass pyramids. The total biomass we measure it by dry weight of organic matter. How do we measure biomass? The dry weight of organic matter of organisms at each trophic level within an ecosystem. This is measured by per year per square meters per gram. That's how we measure this. Energy. Then we have energy pyramid. It's the flow of energy through different trophic levels within an ecosystem. It's how like if you eat 10 calories, not 10 calories, like 1,000 calorie burger, that's those calories, that's the energy we are talking about, okay? It illustrates the amount of energy transferred from one trophic level to the next and highlights the efficiency of energy transfer between trophic levels. It highlights efficiency. This is never inverted. Let's talk about what this inverted and upright is, okay? Upright pyramid is when bottom to the top number decreases. When the foundation is bigger than the next tier of the pyramid, the next trophic level is smaller than the previous one, like 50, 30, 10. That's an upright pyramid. It's how normal pyramids are. Then we have inverted. That's the opposite of it. As in like the beginning is real number, or the whatever quantity there is small, then it's bigger, like 1, 8, 23, like that. So answer, because we have one primary, one provider, one producer, 8 primary consumers, 23 second consumers is 1, 8, 23, because that's number, amount of people, individuals. So it's an inverted number pyramid. The answer to the 7th question is 2. I'd like to quickly talk about how energy pyramids are never inverted. Think of it like this, okay? You, if you're 16, right? Most of you are 16. If you're a boy, if you're 16 and you're mostly grown, like in physical aspect, when a grown male, this is a very weird fact. The whole body, it's like 200,000 calories, 2 lakhs in calories. Imagine for you, normally like 2,500 calories is your daily requirements, right? You eat 2,500 calories. You've been alive for like what, 5,840 days, if you're 16. And if you like roughly calculate the amount of calories you have consumed throughout your lifetime, it would come to like 15 million calories. 15 million calories. I mean, when you're 1 year old, you don't need 2,500 calories per day, but I'm just, assuming. So like 50 million calories, you eaten 50 million calories to become what you are today. But if a bigger animal like a T-Rex comes from the grave and eats you, the T-Rex only gonna get 200,000 calories. It doesn't matter if you had eaten 15 million or 50 million, right? Because your body burns off the calories, and what you have left is what you have consumed in your body, right? It's like body. You don't have you 15 million calories within your body, only 200,000. So therefore, the T-Rex has to eat at least 5 of humans to feel full. So it's like 1 million calories. T-Rex get 1 million calories for like a meal, but T-Rex, by eating you, T-Rex wastes 15 million calories that's been eaten throughout your lifespan. So that's why energy pyramids are never inverted, because no matter how much you eat, the more you eat, the more animals you eat, the more energy gets wasted, okay? 8th question. Here is shown the displacement time graph of the motion of an object during the time intervals from 0 to t1 and t1 to t2. The nature of the motion of the objective is respectively. So this is a displacement time graph. A straight uniform angle upwards, like we can see on 0 to t1, it means a uniform velocity. It means in a unit time, displacement is the same. So it's a velocity, right? Because we measure velocity by displacement divided by time. And a curve to the right as seen on T to T2 means a retardation. Retardation means it's a slowing down. It went up to a normal point, then it made a right curve. If it's like a left curve, as in like it's like curves in and goes up, that's an acceleration. A flat 180-degree straight line, that means a straight line, it, in a displacement time graph, that means it's not moving, the object is not moving, it is still. The more time goes, displacement doesn't change, so that means the object is still, it's not moving. A curve to the left, as the opposite, as I said, is an acceleration. A straight uniform angle down, the opposite of 0 to 2 t1, this means a uniform deceleration. It's a uniform deceleration. So the answer is 2. It's a uniform velocity and a retardation. Then we have the 9th and 10th question. Based on the following information in the illustration, production of hemoglobin is distributed by thalassemia, an inherited disease caused by the gene mutation in a somatic chromosome. Okay, a somatic chromosome means any chromosome that is not a sex chromosome. With regard to the production of hemoglobin naturally, the dominant gene is capital T, while the mutant recessive gene is simple t. ABCD and the indicator of the F1 generation. So ABCD is different kids. First one, 9th question. A thalassemia patient belongs to the F1 generation is. Let's see who it is. As we can see here in the graph, we have unaffected carrier mother and we have unaffected carrier father, right? Because this is what is in capital T and simple t, capital T and simple t. In the graph, it's shown by capital R and simple R, but capital 1 is the unaffected gene, simple 1 is the affected gene. Okay, so this first capital R goes with the dad's capital R, goes with the mom's capital R. It becomes RR, which is an unaffected one. It's a 1 in 4 chance. Then the first R of capital R of the father goes with the second simple R of the mother, goes to R, simple R and capital R, which is a carrier child. It is not unaffected. We need both recessive genes to be affected by this disease. Then we have dad's simple R going with mom's capital R, and that results in capital R, simple R, which is a carrier unaffected child. Then we have dad's simple R going with mom's simple R. This is the issue. This is the child who's affected. Thalassemia is a group of genetic blood disorders characterized by abnormal hemoglobin production leading to an anemia. Anemia is a shortage of red blood cells and related complications, not just anemia, okay? So, both copies of the affected gene, one from each parent, must be mutated for the disorder to manifest. So, the 9th question answer is D, 4. That's the unfortunate child. And then we have the 10th question. The ratio among the thalassemia patients, healthy disease carrier and healthy individuals belonging to the F1 generation. So, affected, we have 1 child, right? Unaffected, we have 2 children. Healthy, we have 1 children. So, the ratio is 1 to 1. Answer is 3. So, that's the 10th question. So, that's it for today. Next episode will be on from question number 11 to 15. Revise this, and if you like the video, and if you have any questions or anything you have to ask, please comment down below. I'll answer. That's it for today. Goodbye.